Hello everyone, welcome again to Hybrid Financial Consultants, and today we are just going to take a look at transportation model. This is for the quantitative technique method. So what are transportation models? Transportation models are just used to solve transportation problems. And what are transportation problems actually? Transportation problems are problems that are faced in transporting various amounts of homogeneous commodities initially manufactured at various locations. So this is our point. You have a lot of products at various locations and you need to move them to different destinations. So from various sources to various destinations. How would you move them in such a way that resources are used optimally? Optimal use of resources. By optimal use, we usually refer to minimization of cost or maximization of profit. So that's our main goal here. Just like linear programming that aims to make optimal allocation of resources, transportation models do the same. So that's what is our focus right now. So let's just take a look at application of transportation models. Where could we apply transportation models? As I just told you, let's say you have production plants in 3 regions, and then we have markets, let's say distribution centers in another region, in other regions, maybe 3 distribution centers in other regions. You will ask yourself how to transport the goods from the manufacturing plants to the distribution centers in such a way to maximize profit or to minimize cost. That will be your concern. So that's why you say application, first of all. Suppose maybe you haven't produced, you are about to produce. That means you will have to buy materials and you will have to take them to production centers. So you can decide the transportation of raw materials from various centers to different manufacturing plants. That's what you can ask yourself. But let's say you produce the goods are ready to be sold. So you can also decide how to transport the finished good from various centers or various manufacturing plants to different distribution centers. You just need to distribute them. But also, let's say you are yet to have a plant. You're asking yourself, I have 4 regions for installing, maybe for initiating the plant. Where should I initiate them? Should I put them at place 1, place 2, or place 3, or place 4? So you presume that you presume to use them all, and then you compute that which would result in the minimum cost, transportation cost, or maximum profit. So that's why you are saying making location decisions for plants as well as warehouses. And lastly, we are told here that helping in locating a new facility where more than one location is under consideration. Of course, these 2 points are just going into one another. That's why I said locating a new facility. You can also try to locate a new facility. So it's just like that. Oh, now, before going further, you have to know that whenever you are dealing with a transportation problem, you will usually form a table of this form. So that's why I decided to put a sample formulation before anything. So as we see here, this is a sample formulation of the transportation problem. When you formulate the problem, you usually put it in the matrix format like this. So these are your sources. You have the sources, source 1, and then we'll have source 2, let's say, and lastly we'll have source 3. All right, each source has its capacity to supply. Source 1 has the capacity to supply A1 units. Source 2 has the capacity to supply A2 units. And let's say source 3 has the capacity to supply A3 units. So that's why we call this one supply. But also, apart from supply, we will have destination because we are supplying somewhere. We are supplying from sources to the destinations so as to fulfill the demand of destinations. We are supplying from sources. We are supplying from sources to fulfill the demands of destinations. So let's say you have destination 1. Destination 1, and then we have destination 2, and also you have destination 3 over here. And destination 1 actually demands B1 units. Destination 2 demands B2 units, and destination 3 demands B3 units, just like this. So these are the demands for each destination, just like this. Be very careful here when understanding the formulation. So let's take a look at what we mean by X and C inside this formulation here. It's very, very simple. C simply means cost. So C11 is the cost to transport 1 unit from source 1 to destination 1. C12 is the cost to transport 1 unit from source 1 to destination 2. C13 is the cost to transport 1 unit from source 1 to destination 3. And then we proceed here. C21, transportation cost per unit from source 2 to destination 1. C22, transportation cost per unit from source 2 to destination 2. And here, transportation cost per unit from source 2 to destination 3. And then we have the last row. That is C31 is the transportation cost from source 3 to destination 1. Transportation cost here from source 3 to destination 2. And here, source 3 destination 3, just like that. All right. After here, you could ask yourself about this X11. This X11 actually represents the units. These are the units that will be transferring. If you say X11, that means you have transferred X11 units from source 1 to destination 1. This is just an example. Let's say if you have X12, these are units transferred from source 1 to destination 2. These ones are the units transferred from source 1 to destination 3. Actually, you go all the way out until you finish them all. So there is something called formulation of the linear programming model. Actually, most of times in an exam, you won't be asked to formulate this because they'll be very, very natural. But what if you were asked? What would you do if you were asked? So that's what we're just going to take a look at. So as usual, even compared to the linear programming model, we usually form the objective function and then we form the constraints. So that's what we're just going to do right here. So what is the objective function? The objective function actually reflects the objective of the problem, maybe to minimize cost or to maximize profit. So that's why you say, if the objective is to minimize total transportation cost, the following can be used. So since you're minimizing transportation cost, you say minimize Z equals to, you sum all the costs that have been used here. Now, as I told you, C11 is the cost per unit. This C are cost per unit and this X are units. So to obtain total cost, you take C11 times X11 plus C12 times X12 plus C13 times X13. You proceed until you finish them all. So that's why to obtain the formula to minimize here, you start C11 times X11, C12 times X12, C13 times X13, and the first row is over. You go to the second row, C21 X21, C22 X22, C23 X23, C31 X31, X11, C31. Oh, I think something is wrong here. Let me make a bit of rectification. Here, C31 X31, C32 X32, C33 X33. The numbers should be the same. There is some sort kind of an error here. This is C31 X31 here. This is not right. Let me rectify it a bit. It should be this way. It should be this way. C31 X31. Actually, it should be this way. It was C31 X31 plus C32 X32 and then plus C33 X33, just like this, and everything is over. So we can proceed now. Now we just go to the constraints. As we saw, we had supply constraints as well as demand constraints, and that's what we are just going to focus on. So since we're supplying, we expect that the supply available actually we cannot fulfill the demand more than the supply we have. So if that is the case, we just go to this point here. If you just go to source 1 can supply a maximum of A1, but this source 1 can supply X11 to B1, X12 to B2, and X13 to B3. So the summation of X11, X12, as well as X13 should not exceed A1. So this one plus this one plus this one should be less than or equal to A1. You do the same for source 2, X21 plus X22 plus X23 should be less than or equal to A2. And here, X31 plus X32 plus X33 should also be less than or equal to A3. And now you have completed the supply constraints. So these are the supply constraints, as you see here. X11, A12 less than A1. The second row, less than A2, and then you go for the third row and you complete these supply constraints. And right now we shift our focus to demand constraints. So as for demand constraints, you see here, these are the demand from destinations. So destination one requires B1 units, right? Destination one requires B1 units. If destination one requires B1 units, that means it would obtain X11 from source 1, X21 from source 2, and X31 from source 3. If you sum them, you would have a total of B1 here. Same for D2, X12 plus X22 plus X22 here, I mean, plus X33 should also be equal to that figure. So that's what we should focus on. And lastly, X13 plus X23 plus X33 should be equal to B3. So just like that, and you complete your formulation of the problem, just like here. So the vertical line there, X11, X21, X31 equals to B1, X12, X22, X32 equals to B2, and lastly, X13 plus something is wrong here too. Let's take a look at the last column. Here, X13 plus X23 plus X33, right? Equals to B3. 1, 3, 2, 3, 3, 3. So you should just be careful here. Actually, let me show it properly. I don't know what was wrong. This is what I was just trying to say. If you take X11 and then you add to X21 and then you add to X21 and then you add to X31, you would have a total of B1. And then if you take X1, hello, are we together? All right, I think you can proceed here. So you can just take a look there and see what you have to do. Right now we are on the second column. So the second column, we can say X12, and then you go down, you will have X22, and then you go down again, and you have X32. This one will be equal to B2. And then you go to the last line, you say X13 plus X23 plus X33. This one would also be equal to B3. So that's what you have to do when dealing with something like this here. And also, I could just extend this first to make these actually are demand constraints. Let me just write here. As I just said, these are demand constraints. Demand. Let me write them well. Demand constraints. All right. Now let's write again the supply constraints. So if the supply constraints, this is what you have to do. So you just come down here and you move to the supply constraints. Actually, I'm just going to show them well. For supply constraint, we're just using a row. So you start with X11, and then you repeat X12, and then you repeat X13, and this one becomes less than or equal to what? That amount of the supply, which we call A, so equal less than equal to A1, and then you go to the second row. We say X21 plus X22 plus here X32. I mean X23. This one should be less than or equal to, let's say, A2. And then you go at the last step. We just go to X31 here, then X32, and then X33. This one is also less than or equal to A3, something like this. And actually, it will be done after this. Let me clear it first, and then let's go to the table. There is some mistakes here, so let's just focus on what I've just shown, not this one. Yeah, this is our table. You can just do the tables very clear from the table. So just view a table here, and then I can do this. Let me paste it back. Let me paste it back. Yes, this one. So these are supply constraints. Supply is here. So x11, x12, x13 less than equal to a1, x21, x22, x23 less than equal to a2, and x31, x32, x33 less than equal to a3. And if for demand, we just go this way. The column wise, x11, x21, x31 equals to b1. So I hope everything is fine on what I've just spoken about. So this is just the initial stage when dealing with transportation problems. And then actually there are several steps that have to be taken to solve a transportation problem. Now, before just going to this problem, I think you can just get a grasp of what we've just done and then we'll proceed further. Thank you very much.